Hi, I am Adeline Abel, and I'm going to explain my assigned task, which are 2.1, 2.4, and 2.8. Okay, so we have problem 2.1. Identify the functional groups in the following molecules. We have three functional groups which that are given. First is for the letter A, we have acrylic acid. Acrylic acid has two functional groups. It is alkyne group and carboxylic acid. That is for letter A. It has two functional groups, alkyl and carboxylic acid. That is for letter A. Now we have letter B, which is aspirin. Aspirin has three functional groups. It is ester, arine, and carboxylic acid. That are the three functional group for aspirin. For letter C, we have glucose. Glucose has six functional groups. These are the structure of glucose, which carbon is bonded to oxygen and also bonded to hydrogen and alcohol. So, six functional groups are aldehyde, and 5 alcohol. Since we have 5 alcohol in the structure, so glucose has 5 alcohol and 1 aldehyde for the functional groups. So that is for problem 2.1. For the problem 2.4, draw structures for the 5 isomers of C6H14. C6H14 is hexane. So it has 5 structural isomers. First structural isomers is this one. It is hexane because it has 1, 2, 3, 4, 5, and 6. 6 bond. For the second structure is this one. It is called pentane because if we're going to count 1, 2, 3, 4, and 5, it has 5 carbon atom, so it is pentane. So it is methyl also because of this bond, which we have CH4. So that is for in the second carbon atom it has methyl, so that is in the 2 carbon it's called 2-methyl pentane. For the third structure we have this one. In the 3 atom it has methyl and it's called pentane because we have 5 carbon atom. For the fourth structure we have butane. It is called butane because it is only has 4 carbon atom, and 2,3-dimethyl because we have 2-methyl. It is in a 2 carbon atom and 3 carbon atom it has methyl, so that is called dimethylbutane. And for the last structure of C6H14 is 2 and 2 dimethylbutane. It is called 2 and 2 dimethylbutane because for the second carbon atom it has 2 methyl, so that is called dimethyl, and it is called butene because it is only have 4 carbon atom. So that is for the problem 2.4, which is going to draw the structure of 5 isomers of hexane, which is C6H14. At this time, for the problem 2.8, identify the carbon atoms in the following molecules as primary, secondary, tertiary, and quaternary. For letter A, we have CH3. CH is bonded to CH3 also. Then CH2, CH2, and CH3. At this number, this carbon atom it is primary. It is because it is only bonded to one carbon. At this carbon atom is tertiary It is because it is also bonded with the 3 carbon, which is 1, 2, and 3. This carbon atom is primary, secondary, and this last carbon is primary. So we can now have 3 primary carbons, which is methyl, and 2 secondary carbon, which is methylene, and 1 tertiary carbon, it is methane. Okay, for the next number, we have letter B. It is CH3, CH2, CH, which is bonded to CH3, CH, and CH3. CH is also bonded to CH2 and CH3. Carbon CH3 or carbon methyl, it is bonded to CH2. So this carbon is a primary carbon. This second carbon atom is bonded to 2 carbon. It is left and to its right. So this carbon atom, which is CH2, is secondary carbon. The third carbon, which is CH, is bonded to 3 carbon atom, CH2 and CH2, and also to CH. So this carbon atom, which is bonded to 3 carbons, it is identified as tertiary carbon. At this carbon, it is bonded to also 3 carbon atom, 1, 2, and 3. So it is identified as tertiary carbon. This carbon atom is only primary carbon, and also this carbon atom is only primary carbon. It is because it is only bonded to 1 carbon. To this carbon atom, it is identified as secondary carbon. It is because it is bonded to 2 carbons, 1 and 2. So it is secondary carbon. The last carbon atom is identified as primary carbon because it is only bonded to 1 carbon atom. So there we have our 4 primary carbon atom and 2 secondary carbons and 2 tertiary carbon atom. That is for item letter B. For the item letter C, which has CH3, is bonded only to CH. So this carbon atom is primary carbon. CH is bonded to CH2 and CH3 also to CH3. So this primary carbon is tertiary carbon. It is because it is bonded to 3 carbons. CH3 is identified as primary carbon because it is only bonded to CH. So it is primary carbon. CH2 is identified as secondary carbon because it is bonded to 2 carbon atom. Next, we have carbon. We have only carbon because it is bonded to 4 carbon atom, which are CH3, CH3 in the down, and CH2. So carbon is bonded to 4 carbon atom, so it is identified as quaternary carbon. For the last carbon atom, we have CH3 or methane, which is bonded to 1 carbon, so it is identified as primary carbon. We have 5 primary carbons and 1 secondary carbon, 1 quaternary carbon, and we also have 1 quaternary carbon atom. That is for problem 2.8 for letter A, B, and C.
Good day, Miss Mel. I am Grazel L. Arabis. and I am from Group 9, and I will be the one explaining on our answers in problem 2.9 and problem 2.10. So here is our explanation. So in learning activity 3, problem 2.9, give IUPAC names for the following alkanes. A. The three isomers of CpH12. So in your video, ma'am, you state there that if the problem asks for the isomers of that particular formula, you said that the normal one will be also written. So it is like this, ma'am. This is the normal pentane. Pentane means 5. So 1, 2, 3, 4, 5. And then our second answer here is 2-methylbutane or isopentane. Here is the structure of 2-methylbutane. Butane means there are 4 carbons. One, two, three, 4. But there is also 1 carbon here, but the 4 carbons is the longest chain. So that is called butane. The parent name is butane. It is methyl because CH3 is methyl. But if there is 4 carbons, it is methane. If we wrote it in a condensed formula, CH3 CH3 CH2 CH3. So this is the condensed formula. So this is the second isomers of C5H12. The next is 2,2-dimethylbutane or neopentane. This is pentane, sorry. So here is the structure of dimethylpropane. So it is propane because the longest chain is 3 carbons, so it is propane. It is dimethyl because there are 2 methyl. First is this one. This is the first methyl and the second methyl. If we wrote this in a condensed formula, this is CH3 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 CH3. So this is the third isomers of C5H12. B is CH3 CH2, and there is alkyl here, up here in CH. The alkyl is CH3, next is CH. The alkyl down here is CH2, CH3, and then CH3. So first we will count what is the longest chain. The longest chain is 1, 2, 3, 4, 5. Therefore, it is a pentane. Pentane. And then we will number it. So I will number it here first. Because the first here is the nearest in the first carbon. So the next thing to do is find the substituent. So substituent. So 1 no, 2 is meron. So it is 2 and this is ethyl. 3 meron. And it is methyl. And then I will put pentane here because this is the last one. And we will order it in alphabetical. But it is E is the correct and M is also correct. So it will be the final name of this IUPAC is 2-ethyl 3-methyl pentane. So let's proceed to C. CH3 CH, and then there is a alkyl up here, CH3 CH2 CH, and also alkyl here and CH3. So we will count the longest chain. 1 2 3 4 5. So it is the same. It is also pentane. Then we will number it. I will just number here because it is the same. There are the same. Substituent. There is substituent in the 2, CH3, which is methyl, and 4 is also methyl. Therefore, there are 2 same methyl, and the parent name is pentane. So we will write it dimethyl pentane. So this is the name of the IUPAC structure. So let's proceed here in B. The given is CH3, C, alkyl up here, CH3, alkyl down here, CH3, and then CH2, CH2, CH, alkyl also here, CH2, CH3, and then CH3. So we will count the longest chain. 1 2 3 4 5 6. So it is hexane. Parent name is hexane. Second is we will number it. So I will number it here first. 1 2 3 4 5 6. Then I will write down the substituent. So there is no in 1. 2 is 2 ethyl. Fifth, there are 2 ethyl, so di, and then the parent name. Then we will arrange it into alphabetical order. But this one, di, is not included. is methyl 5 dimethyl hexane. Learning Activity 3, Problem 2.10. Draw structure corresponding to the following IUPAC names. So let's proceed in A. 3,4 dimethylnonane. So it says 9 is the longest carbon chain. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I'll number it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, substituent, 3, CH3 is methyl. In 4 there is also, because it says here 4 is also methyl. And the longest carbon chain is nonane. So we'll put nonane here. But there is 2 methyl. So it is 3, 4, because it is same. 3, 4 dimethylnonane. But I'm gonna draw it a structure. So we'll start here. Carbon 1, carbon 2, carbon 3. There is alkyl here. Carbon 4, alkyl here. Carbon 5, carbon 6, carbon 7, carbon 8, carbon 9. So this is the structure of 3,4-dimethylnonane. So let's proceed here in B. The given is 3-ethyl 4, 4 dimethylheptane. So here is this structure. It says heptane, so 7. 1, 2, 3, 4, 5, 6, 7. Then number 1 here. 1, 2, 3, 4, 5, 6, 7. It says 3 ethyl. So I put ethyl here. CH2, CH3. And then in 4, it says dimethyl. So 2 methyl. And then the parent name, 7. So the substituent, same here. The other structure is this. So first carbon, 1, C. Second carbon, 3. Third carbon, C. And then the CH2, CH2, CH3. It's here. And then in 4, it's 4 here. It says 2 methyl, 2 carbon. And then 4, 4, 5, 6, 7. So here in C, given is 2, 2 hyphen dimethyl hyphen 4 hyphen propyl octane. So octane has 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. I will number it. 1, 2, 3, 4, 5, 6, 7, 8. So it says 2 methyl. So in 2 there is also 2 methyl. So here 4 propyl octane. Propyl. So when I say propyl, it is C3H7. But if it is propane, it is C3H8. But it says propyl, so we will go here. That's why I wrote C3H7. So in 5H C and then up to here. So let's go to the next structure. Let's say 1 carbon, 2 carbon, and then in 2 carbon there is 2 methyl. Here 3, 4. So in 4 there is propane. So this is propane because it says 3 carbons. 1, 2, 3, and then 4, 5, 6, 7. So let's go here to the next structure. So first carbon 1, carbon 2, there is 2 methyl. So here, and then third carbon, fourth carbon, and fourth carbon there is propyl. So here is the propyl. Here 5 carbon, 6 carbon, 7 and 8. Let's proceed here in D. 2, 2, 4 hyphen trimethyl pentane. So the parent name is pentane. So there is 5 carbon. So 1, 2, 3, 4, 5. Let's number it. 1, 2, 3, 4, 5. So in 2 there is 2 methyl because the 2 is repeated here. 2. Then 4, there is 1 methyl. Therefore, it is trimethyl because there is 3 methyl. So the other structure is this one. So 1, 2, 2 carbon, 3 carbon, 4, 5 carbon. So in 2 carbon, in second carbon, there is also 2 methyl. 1, 2. In fourth carbon, there is 1 methyl. So this one. So this is the structure of trimethyl pentane. Learning activity 4. Problem 2.12. Cite along a carbon-carbon band of propane and draw a Newman projection of the most stable conformation. Draw a Newman projection of the least stable conformation. So first, we look for the propane. So the formula of it is CH3, CH2, and then CH3. And then this is the structure we draw. H, and then this one is the carbon. The other one is H, and then CH3. Because it states here that there is a 3 hydrogen and then 2 hydrogen and then CH3. We just wrote CH3 there because we are looking for the Newman projection. Okay, then it says here, draw a Newman projection of the most stable conformation. So it said that it says that the most stable conformation is called staggered. So staggered is far as possible. So we draw this. This is the second carbon, the first carbon. So hydrogen stays away from each other. So look, it's far from each other. So this is what we draw, staggered. And then it says the other, draw a Newman projection of the least stable conformation. So least stable conformation is eclipse. So close sila, unlike sa staggered nga lagyo. So here, so the hydrogen is close to each other. This is CH3 because there is CH3 there, and then 5 hydrogen to each other. 1 2 3 4 5, and then 5 also hydrogen here. 1 2 3 4 5, and then the other hydrogen or the CH3 is here. So this is our answer, ma'am, in problem 2.12. Let's proceed to problem 2.16. Propose a skeletal structures for the following molecular formula. So the first given is C4H8. So this is what we draw. First, we draw the structural. It says 4 carbon. So here's the 4 carbon, and then 8 hydrogen. 1 2 3 4 5 6 7 8. So therefore, this is the skeletal structure. 4 carbons. 1 carbon, 2 carbon, third carbon, then fourth carbon. Let's proceed to given letter B. C3H60. So it says 3 carbon. 1 2 3, and then 6 hydrogen. So 1 2 3 1 2 3, and then 1 O. I put O here. Okay, and then this is the skeletal structure we draw, ma'am, because 1 carbon here, 1 carbon here, and then 1 carbon here, and then 1 O in the upside, ma'am. And then the last given is letter C, C4H9, and then Cl or chlorine. So first we draw the 4 carbons, 1 2 3 4, and then 9 hydrogen, 1 2 3 4 5 6 7 8 9, and then 1 chlorine. So I wrote chlorine here, and this is our skeletal structure for this molecular formula, ma'am. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and then the chlorine is over here. So that is our answer, ma'am.
Good day, Mamel John B. Dizon. I am Ramon B. Bilutindos, a first-year college student taking BSA major in Agronomy, Section A. And I am the leader of the Group 9 in your subject, AG 104, Organic Chemistry. And today, I am going to explain my part in the learning activities. And I will be explaining the problem 2.18, 2.19, 2.20, and 2.21. So, here is the learning activity for problem 2.18. Give the IUPAC name for the following cycloalkanes. So this is the cycloalkanes. These are the cycloalkanes. And the first one in letter A, this one named the dimethyl cyclohexane. This is because that this cycloalkanes is called the cyclohexane because it has six carbon atoms. So 1,4-dimethyl cyclohexane because the first methyl is in the first position, then the fourth one, the methyl also is in the fourth position. That's why 1,4-dimethyl cyclohexane. The second is the dimethyl cyclobutane. So this has a 4 carbon atoms, so that's why it is called dimethyl cyclobutane because in the first position there is the methyl. So here 1,1-dimethyl cyclobutane because in the first position there's a methyl here and combined with this cyclobutane, so it is dimethyl cyclobutane. So the third one in letter C, the 1-methyl 3-propyl cyclopentane. So this is the cycloalkanes that has 5 carbon atoms, so that's why it is called propyl cyclopentane because here is the propyl. This CH2CH3 is a propyl that is positioned here, so that's why this is called 1-methyl 3-propyl cyclopentane. So we will move on to problem 2.19. Draw structures corresponding to the following IUPAC names. So the IUPAC name is 1/3 butyl 2-methyl cyclopentane. So this is the structure of 1/3 butyl 2-methyl cyclopentane. So this has the 5 carbon atoms here, so that's why it is called pentane and cyclopentane. And here position the first, the third, and the butyl, the 2 butyls here. So this is called the methyl cyclopentane. Okay, letter B is 1,1-dimethyl cyclobutane. So this is the cycloalkanes called the cyclobutane that has 4 carbon atoms, and 1,1 that is positioned here. So this part here is the methyl, and if it is combined to the cycloalkanes that is called cyclobutane, so it is now called the dimethyl cyclobutane. Okay, letter C. Next, cycloalkanes called the isopropyl cyclohexane. So this has the 6 carbon atoms, so that's why it is called the cyclohexane. So 1-ethyl, this is called this 1-ethyl means that the ethyl is positioned in the first carbon atoms, then the isopropyl is substitute in the fourth atom. So 1, 2, 3, 4. So here is the isopropyl here. So if it is combined the whole, so that is called the ethyl isopropyl cyclohexane. So letter D, 3-cyclopropyl hexane. So this is the structure of cyclopropyl hexane. This has the 3 cyclopropyl, and if this the whole one cycloalkanes, this is now called the cyclopropyl hexane. Okay, let's move on to problem 2.20 in learning activity 4. Draw CIS 1-chloro 3-methyl cyclopentane. So this cyclohexane is called cyclopentane because this has the 5 carbon atoms, and 1-chloro, this means that the chlorine is positioned here in the first atom. Then the 3-methyl is substituted here in the third carbon atom side. So if this will be combined, so this is the chloromethylcyclopentane. So this is the structure of chloromethylcyclopentane. So let's move on to problem 2.21. Drew CIS and trans isomers of 1,2-dibromocyclobutane. So this structure is this cycloalkane is called the cyclobutane. This one. So this first picture shows the trans isomers of dibromocyclobutane. So the bromine is presented here in the different planes. So the bromine is presented here at the first position, then the bromine that has a different plane. So here is another bromine, so it has another shape, another plane. So that is the trans isomers. And the other picture is the CIS dibromocyclobutane. So this is also the cycloalkanes called cyclobutane, which has the same plane. The first bromine is presented at the top and first position, then second one in the second position of bromine. So that is the CIS of 1,2-dibromocyclobutane. So that's all my part, ma'am. Thank you.